Good day, everyone. Today, I'm going to discuss some of the basic rules in deriving a function. So this would be the foundation for our differential calculus. So some of the rules would be the derivative of any constant would be always equal to 0. Again, the derivative of any constant, whether it is a negative value or a positive value, as long as it is a constant only, a constant alone, that would be always equal to 0. And if we have a derivative of constant times any term, we could rewrite it, the constant in front of our derivative operator times the derivative of that term or of that function. Next, we have the derivative of a sum and difference. To take that derivative of any polynomial, we could take the derivative of each terms. Next, we have the power rule. The power rule states that we could have the exponent in front of that function, then that base form, copy it, and then that exponent will be deducted by 1. So let's try to apply these basic rules in our examples. So first, we have the derivative of x squared plus 3. So we could always write it as the derivative of a sum of terms. So that would be the derivative of x squared plus the derivative of our constant 3. So simplifying it, we could observe here that we could now follow this basic rule of power rule. So take the exponent in front, so that would be our exponent is 2. So copy 2, then copy our base form, which is x, and exponent of 2 minus 1, since we have n minus 1 here, plus the derivative of our constant, which is stated that it would be always 0. So we have here plus 0. So our final answer would be 2x. And that's it. Now, let's have our second example, which is the derivative of 2x exponent 4 plus 5x. So again, the derivative of a polynomial could be rewrite as a derivative of each terms. So we could also write our constant in front of our derivative operator. So this would be the derivative of x exponent 4 over dx plus 5 dx over dx. And this would be parenthesis. So we could simplify our answer applying the power rule in this term as 4 as our exponent. So we have to bring down our exponent. Then we have to write our base Then copy the exponent, deduct it by 1. So that is 4 minus 1 plus the next term, which is 5. And simplifying this, we have dx over the derivative of x over dx that would be equal to 1. So we have our final answer. 2 times 4, that would be 8. And x exponent 4 minus 1, that would be cubed, plus 5. So this would be our final answer. So what if we are asked to get the derivative of a function that has a square root? So we have just to use the conversion of that square root into exponential form. So we have to take note that our square root could be expressed as an exponent. So this x, or square root of x, could be expressed as x exponent 1/2. So we have to rewrite it as an exponent, so that would be the derivative of x exponent 1/2 now. Then again, we could apply our power rule, wherein we have to copy its exponent in front, so that would be 1/2. Then copy its base, which is x. Then its exponent deducted by 1. So that would be 1/2 minus 1. So our answer here would be 1/2 times x exponent negative 1/2 now. And we could always rewrite this as a positive exponent. So that would be 1 by bringing it into its denominator with the x exponent 1/2. And we could rewrite it as a function or in terms of square root. So this would be 1 over 2 square root of 2. I mean square root of 1 over 2 square root of x. So that's it. Our fourth example is a derivative of a function that has a negative exponent, or it is in the denominator side. So again, this 1 over square root of x could be expressed as an exponent of x exponent negative 1/2. So we could actually take the derivative of x exponent 1/2 now using the power rule. So applying the power rule, copy the exponent, which is negative 1/2, then copy the base and exponent, but deduct its exponent by 1. So this would be equal to negative 1/2 of x exponent negative 3/2. And we could express this exponential form as in this form, which is negative 1 over 2, and this would now become x exponent 3 and that would be square root because x exponent negative 3 halves, its exponent could be expressed as a positive value by bringing it down to its denominator, which is x exponent 3 halves, then express it as square root, but it is x cubed now. So we have our answer as the derivative of 1 over square root of x, which is negative 1 over 2 square root of x cubed. And let's have now our last example for this video, which is the derivative of 5x raised to the exponent of 2/3. So again, we could write the constant in front of our derivative operator. And we could have 5 times the derivative of x exponent 2/3. And now, since we have this exponential form, we could apply the power rule. Copy the constant, then bring down the exponent, which is 2/3. Multiply it by its base, then copy the exponent, but deduct it by 1. So this now would become 10/3 times x exponent negative 1/3. And we could rewrite it again into 10 over 3 and so that it would become a positive exponent, we could bring it to the denominator side. So that would be x exponent 1/3 if it is brought down, and if expressed in a cube root, so this would look like this. So we have the final answer, 10 over 3 cube root of x. So thank you for watching.